Hi guys, our next section in the unit is adding and subtracting. So we've done simplifying, multiplying, and dividing, and now we're adding and subtracting rational expressions. So let's just jump right into this. Think about how you add or subtract two fractions, and to do that, the denominators have to match. So in number one, the denominators are both x plus 3. So great, we have a common denominator of x plus 3. All we have to do is add 2 plus 5, which is 7. You always want to check that nothing cancels and nothing does, because x plus 3 is a binomial, and that's your answer. Ta-da! I know, I wish they were all that easy. Number 2, look at this. This denominator and this denominator are exactly the same, so let's write that down. And then in my numerator, just to write this out, I'm doing 2n plus 1. Be careful with your negative. This is where people always mess up. You're going to minus 3n, and then also distribute into the 4, so I'll be subtracting 4. So 2n minus 3n is a negative n. 1 minus 4 is a negative 3. Now, I'm going to try to factor this denominator in case something does cancel. That is something you have to check. So I'm going to have a 2n and an n. So let's see, factors of 3. So I think I could put a 3 here and a 1 here. So that's going to give me 2n squared, a 6, and a negative 1 would be a 5. So does this work? Let's see. So there'll be a 2n squared, a 6n, minus 1n would be 5n, and a negative 3. Yeah, that factors. So you might be looking at this and be like, well, you're done and that was a waste of time. Well, sometimes it might be a waste of time, but guess what? This time it wasn't, because this numerator is almost just like this term here in the denominator. We talked about this last section. What can you do in your numerator here to make this look exactly like n plus 3? I hope you're saying factor out a negative from the top. I did not leave myself enough room. So what happens now? Look at, they cross out. And so you are left with, in Mrs. Swanson's style of not leaving yourself enough room, what's left on the top? A negative 1 over 2n minus 1. No, the negative 1s do not cancel. This negative 1 is part of the binomial in the denominator. And you're done. All right, now let's look at ones where the denominators are not the same, and we'll start off with an easy one. So we have a 3x and a 6. So let me ask you this. What if you were doing 1/2 plus 1/6? What would you tell me is the common denominator? Well, actually, let's make it even more similar to this problem. What if it was 1/3 plus 1/6? What's your common denominator? You're going to tell me 6. What do you multiply 3 by to get 6? You're going to tell me 2. And you'd have to multiply the top and bottom by 2. Well, same difference here. Forget about the variables for right now, and I want you to just look at your numbers. How do you go from 3 to 6? I got to multiply by 2. This one needs to have a 2 multiplied by it. Okay, so that will turn this to a 6. But what does this denominator have that this one doesn't? Now you have to look at the variables, and the answer is an x. So you have to multiply this one by x over x. So some people like to write a note to themselves. CD, your common denominator, is 6, because that's what 3 and 6, that's the least common multiple of them, both of those numbers. And then an x. This has an x, this one doesn't. So now I multiply. 2 times 2 is 4. 2 times 3x is 6x, which is what I'm supposed to get. 1 times x is x over 6x. Don't go and cross out and simplify. So many people are like, oh, let me cross off these x's and let me simplify the 4 and the 6. No, you just are going to undo all the work you did. So keep your denominator of 6x, and then your numerator is 4 plus x. Okay? Nothing cancels here. The x's do not cancel because your x in the numerator is part of a binomial. All right, let's look at number 4. So if you take what I just gave you and the hints that I just gave you in the last problem, come on and focus. First, look at your numbers in the denominator. So 7 and 3. What's the least common multiple of 7 and 3? What do they both go into? Hopefully you're going to tell me 21. Okay? And now let's look at your variables. Y to the fourth and y squared. So it's going to be y, but to what power? You take the smaller one and say, well, can I make this 2 and 2 a 4? Yeah. So always take the larger variable. Okay? So then you look and you say, okay, well, that's my common denominator. So what parts of the common denominator am I missing? How do you make the 7 a 21? We're going to need a 3. And do we need to get the y to the fourth to a y to the fourth? No, we already have a y to the fourth. Now let's look at this one. I'm going to write it here because I didn't give myself enough room. How do we get 3 into 21? Got to multiply the top and bottom by 7. And how do we make a y squared into a y to the fourth? We need a y squared, because y squared times y squared is y to the fourth. Now you multiply. 3 times 3 is 9. 3 times 7 is 21 y to the fourth minus 7y squared times 2. That's going to be a 14y squared. 7 times 3 is 21. Y squared times y squared is y to the fourth. Phew, the denominators match like they should. So let's write down our denominator, 21y to the fourth. Our numerator is 9 minus 14y squared. Now, stop and check and see if you can factor anything. 9 and 14, do they have anything in common that you can factor out? The answer is no. 14 is not a perfect square. I would think that maybe I could factor this because of the y squared and the 9, but you can't because 14 is not a perfect square. Also, you cannot cross out the y squared and the y to the fourth because the y squared is part of a binomial in your numerator. Okay, let's move on. Number 5. So for this one, some people might opt to simplify. Actually, you can't. 4 and 25. I don't know what I was thinking. So neither of these fractions can be simplified. So let's look at our common denominator. Look at the numbers first. 25 and 100. What's the least common multiple of 25 and 100? What's the smallest number they both go into? The answer is 100. Now let's look at the variables. This one has an x, this one doesn't. So you need an x in your common denominator. Okay, so how do we make 25x into 100x? 25 times what gives you 100? 4. So 4 over 4. And how does 100 turn into 100x? Need to multiply the top and bottom by x. So here we go. 4 times 4 is 16. 4 times 25 is 100x minus 49 times x is 49x and 100x. So our denominator is 100x. Numerator is 16 minus 49x. Can I factor anything out of all of those? I don't think so. That's my answer. They're not pretty answers. You're gonna pause with me while I come down here to plug in. Okay. I always seem to run low on batteries when I'm doing your videos. I don't know why. Alright, so now if my cord just could not be in the way, that would be the best. Alright, so there's your answer for 5. Let's try another one. Number 6. Sorry, my cord is not working with me here. Alright, so let's look at our common denominator. So we're looking at 12 and 36. What's the least common multiple, if I could not get the shadow in the way, that would be cool, of 12 and 36? Well, hey, great news. 12 can go into 36. And now let's look at your b's. So this is b to the first and b squared. Remember I told you up in number, 4, that you need to take the higher of the two exponents, so b squared. Okay, so how do we turn 12b into 36b squared? Well, we need a 3, because 12 times 3 is 36, and then we need a b, because b times b is b squared. This one we don't have to do anything to it, because it's already 36b squared. So 3b times 5 is 15b over 36b squared, and I didn't do anything to the other equation. So now, here we go. Our common denominator is 36b squared. My numerator is 15b plus 15. Okay, so like I said, always try to factor. So in your numerator, can we factor anything out of 15b and 15? The answer is yes, a 15. So you get 15 times the quantity of b plus 1 over 36b squared. Now I did that because I can simplify this more. 3, I noticed, goes into 15 and 36. So dividing 15 by 3 gives me 5, and dividing 36 by 3 gives me 12. So my final answer is 5 times the quantity of b plus 1 all over 12b squared. There's number 6. I'm doing up to number 11, I believe, if you're wondering how many I'm doing, because they get progressively harder. All right, so number 7, now our denominators are different. Comments that people usually make are, well, they both have a c. Well, yeah, but remember, it's c plus 2, that's a binomial, and c minus 3, that's a binomial. They belong together. So this gets a little bit complicated. So my common denominator, when you have a binomial that is a group that can't be broken up, your common denominator is the product of those two binomials. Okay, so the first one we have to multiply by c minus 3 over itself, and the second one you have to multiply by c plus 2 over itself. So here we go. I'm going to kind of cut down on my work a little bit now that we're on number 7. So I have 5 times the quantity of c minus 3 plus 6 times the quantity of c plus 2 all over. I'm going to leave the denominator in factored form in case something cancels later. Please don't tell me the c plus 2's cancel and the c minus 3's, because they don't. There's addition here. We have to distribute in and combine like terms. So in your numerator, you're going to get 5c minus 15 plus 6c plus 12. Again, don't FOIL the denominator because things might cancel. So let's see, 5c and a 6c is 11c. Negative 15 and 12 is going to be a negative 3. So you want to try to factor that numerator. 11c and minus 3? Nope, can't do anything. That's your answer. Number 8. Again, yes, there are 1's, and yes, there are m's, but they are part of binomials that can't be taken apart. So this is another situation where your common denominator is the product of those two binomials. So that means I have to multiply the first one by m minus 1 over itself. I'm going to use parentheses. And the second one by 2m plus 1 over itself. Come on and focus. So my first numerator, this thing would just come to focus here, okay, is going to be m times the quantity of m minus 1. Notice you're subtracting, so I'm going to write minus 3 times the quantity of 2m plus 1, all over my new denominator of m minus 1 times quantity 2m plus 1. Now let's distribute. I'm going to get m squared minus m. Now I'll distribute in the negative 3. Minus 6m minus 3. All over. Again, don't FOIL that out. Your denominator. And please write it out. Some of you get lazy and you skip it, and then in the end you just forget about a denominator. So this gives us m squared minus 7m minus 3 all over m minus 1 times 2m plus 1. So I feel like this should factor, but let's think about it. Can we find factors of negative 3 that are going to add to negative 7? The answer is no, it's not possible. We can't do that. So can't be factored, nothing's going to cancel. That's my answer. All right. Number 9, let's look at one where you don't actually have a denominator in one of them. Remember, that's technically 1. You can put anything over 1 and it's still that number. So in that case, your common denominator is just the one that's written, 2x minus 3. So that means I don't have to do anything to the first fraction, but the second fraction I have to multiply by 2x minus 3 over itself. So I have x minus 11 times the quantity of 2x minus 3 over my common denominator of 2x minus 3. Guys, these 2x minus 3's don't cancel. You have a binomial up here right now. Okay, please, those do not cancel. So let's distribute in. Negative 11 times 2x is negative 22x. Negative 11 times negative 3 is positive 33. Okay, so 1x minus 22x, that's going to be a negative 21x plus 33 all over 2x minus 3. Again, if you can factor, you should. So what goes into 21 and 33? I'm thinking a 3, and we're going to take out a negative so that this first term's positive. So I'm going to take out a negative 3, and that's going to leave me with a 7x minus 11 over 2x minus 3. So if these were to cancel, my two parentheses here would have to match, but they don't. So again, the negative 3's, those cannot cancel. This is part of a binomial right here. So that's my answer. That was a situation where factoring didn't help you. All right, number 10. Here's a situation where your two denominators are not factored, and it's a binomial that with a squared term and a trinomial with a squared term. So before you can establish the common denominator, excuse me, you need to factor. So x squared minus 9, that's difference of perfect squares. So it's x plus 3, x minus 3. And then I'm looking for factors of 9 that add to 6. So that's going to be x plus 3, x plus 3. All right, so now that I'm in factored form, let's look and see what they have in common. So they each have an x plus 3. So let's write that down. Okay, this one has an x minus 3. This one has an extra, we'll say, x plus 3. So I have to include both of those in my list. So I really need to write down two x plus 3's, because again, they only share one of the quantity x plus 3's. Come on and focus. Anytime. Make this video shorter for these people. And this x plus 3 is an extra one, so we need to include that. We also have to include the x minus 3. Okay? So looking here, what's the only thing we need to multiply by? X minus 3 over itself. Oh, no. I'm sorry. This is a minus. We need the extra x plus 3, excuse me. We have an x plus 3 and an x minus 3. We need an x plus 3. This one is the one that needs the x minus 3. Okay, so here we go. We have x times the quantity of x plus 3, and then remember we're subtracting x times quantity x minus 3 over, it's x plus 3 squared. There's two of them. I have a lot to write. I don't feel like writing x plus 3, x plus 3. All right, so now we distribute. X times x is x squared plus 3x, and then we have minus x squared plus 3x all over quantity x plus 3 squared, x minus 3. Hey, the squareds cancel. 3x plus 3x is 6x over x plus 3 quantity squared, x minus 3. Nothing cancels. You're done. Sorry about the shadow. Okay, and the last one, I want to do one more with the denominator not factored. So, looking at your first denominator, you hopefully would want to take out an x so that you can factor this. And you're left with x squared plus x minus 10. And there's nothing to do here on the right. So now, can we find factors of negative 10 that give us 1? So if you think about that, we've got, what are you going to say? Hopefully you're going to tell me 10 and, actually no, nothing. All right, so, I don't know, I was thinking 9 and 10 in my head. You know me. All right, so I'm writing my common denominator over here because I actually have room. Okay, so look, we have an x, and then quantity x squared plus x minus 10, and then an x plus 5. So these two fractions have nothing in common, so we have to list everything. We need the x from right here. We need this trinomial of x squared plus x minus 10, and then we need the binomial of x plus 5. Oy, oy, oy. All right, I'm just going to cross this out so I can skip it, that step. So this fraction needs the x plus 5. Guess what section I got this one from, guys? The challenge section. This is one where I would give you in class, and I'd say, who can figure it out first? And I'd walk around, and I'd say, yes, no, you got it, you didn't. Remember that? Oh, the days, the good old days. Okay, so here we go. We have a 7x minus 10 times x plus 5. There's a lot to write for this one. I'm going to FOIL this right now. 7x times x is 7x squared. 7x times 5 is 35x minus 10x is a 25x. And then a minus 50. Okay. This one. This is a negative 1 times x. So just for the sake of remembering that we're subtracting, I'm going to just write that down. And our new denominator is x times x squared plus x minus 10 times x plus 5. Okay, so let me distribute in that negative x so people can see what's going on. So we're going to get a negative x cubed minus x squared plus 10x all over our lovely denominator. I know I'm sick of writing it too. Okay, so let's combine like terms. Put it in standard form. So we have a negative x cubed, so that's gone. A 7x squared minus x is going to be a 6x squared. And then a 25x and a 10x, sorry, is 35x and then minus 50. All over x times x squared plus x minus 10 times x plus 5. And so, I'm thinking that we could try to factor this. And the numerator you would have to factor by grouping, which remember is you would cut it down the middle and you'd say, well, hey, what do these two terms have in common? You'd tell me x squared, and it would have to match what you factor out over here, but it's not going to work. It won't be factored. So, there is your beautiful answer. We're going to spend today and probably Monday on this, maybe Tuesday. We'll see how you do.